All right, continuing on this chapter 3 review. The next section is solving equations, which is what we've done most recently. So hopefully this is pretty familiar. Make sure if the problem can be solved without logarithms. So if you can match bases, then you need to do that because your answers need to be in the simplest form. All right, so for the first one, this is base 10. I'm going to isolate this term by subtracting 2. So it's 3 times 10 to the 2x minus 3 equals 13. And then I'm going to divide by 3. And once you've isolated the exponential term, you can log both sides. I want to log base 10, so common log both sides. That's because the common log cancels out the base 10. So you're left with 2x minus 3 equals the log of 13 over 3. And these are all non-calculator problems, so we're just going to leave our answers with the logs in them. To solve for this, you would add 3, divide the whole thing by 2. So it'll be log of 13 thirds plus 3, divide the whole thing by 2. And that's our final answer. For number 29, I guess you could do this two ways. You could rewrite it so that it's 5 times e to the negative 2x, or I just multiplied e to the 2x over here. And then I divided by 20, so 5 divided by 20 is 1/4. So if you don't do that, it would be e to the, if you did it the other way, it would be e to the negative 2x equals 4 if you just rewrote this exponent and divide 5 to that side. I want to get rid of the base e, so I'm going to natural log both sides. So the natural log and the base e cancels out, so that's just 2x. And then to solve for x, I'll divide by 2. So the natural log of 1/4 divided by 2 equals x. So if you have an answer of the natural log of 4 divided by negative 2, that's equivalent because we can work on condensing and using logarithm properties to get our answers to match. So number 30 is an example where I've got two different base numbers on either side, and I can rewrite them so they're both base 3. So 81 is 3 to the 4th. So if this is 1 over 81, this is really 3 to the negative 4th being raised to the 3 minus x power. And 27 is 3 to the 3rd being raised to the 1/2 x plus 2 power. And when you have power to a power, you multiply your exponents. So 3 to the negative 12 plus 4x equals 3 to the 3/2 x plus 6. If these are both base 3, I don't need the bases. I can just set the exponents equal to each other. Or another way to think of that is you could say you're going to log base 3 both sides. But either way, you get it to setting the exponents equal to each other. And then we just need to solve. So if I do 4 minus 1/2 or 8 over 2 minus 3 over 2, I get 5 over 2 x. So then I need to add the 12 over to this side to make 18. To get rid of the 5 over 2, you multiply by 2/5. So x equals 36 over 5. All right, for 31, this is our first, our first log equation. So if I have 2 logs and not a 0 on this side, then I need to condense first. So condense this into one single logarithm. Because we're adding the logs, you multiply the results together. So x times x plus 3 is x squared plus 3x equal to 1. All right. And now that you've got it down to a single logarithm, you need to get rid of the log by making both sides base 4. So I usually just show that work like this. So the 4 and the log base 4 cancel. You have x squared plus 3x equals 4 to the first. Excuse me. And then this is a quadratic, so get it equal to 0. You should factor this into x plus 4, x minus 1. Solutions temporarily are negative 4 and positive 1. Remember, for the log equations, so really just for 31 and 32, that's it. The rest are exponential. I need to check my answers for extraneous solutions for those two. For exponential equations, you can have any real number. The domain for exponentials is all real numbers, but the domain for logs, you can only log a positive value. So -4 is out because the log base 4 of -4 isn't going to work. There's no exponent I can raise 4 to make it come out negative. 1 is okay because you can log 1, you can log 1 plus 3. So x equals 1 is the only solution here. It doesn't mean that you always throw out negative answers, by the way. It's just when you plug in the negative answer, if the rest of the expression doesn't cause the entire expression to be positive, then that's why we throw that out. Okay, on number 32, I've got logs all over the place here, so I'm going to condense each side. I'm going to condense this with division because we're subtracting the logs. So this is the natural log of x over x minus 1 equals the natural log of x plus 1 over x squared minus 2x plus 1. Now this is x plus 1 squared. And I know we talked about this in the notes before too. I was sort of leery of like simplifying and canceling things, but thinking more on this, I think with our log equations, we can get away with reducing this expression, and we shouldn't lose out on a solution. Because I think what we would be doing if whatever solution we get that we cancel, I think it would cause an extraneous solution anyway. So I'm just going to reduce this to the natural log of 1 over x plus 1. All right, so if these two logs are equal to each other, then I can drop the natural log part and just say that means that x over x minus 1 has to equal 1 over, oh, this shouldn't be x plus 1, sorry. This should be x minus 1. Oh, wait, maybe that's why I can't cancel. Okay, so sorry, I can't simplify this. Hold on. Let me fix this. I think I need to fix my key now too. Okay, this is x plus 1. I got ahead of myself here. This factors into x minus 1 squared, so that does not cancel. Okay. So for this one, if I set these equal to each other, I get x over x minus 1 equals x plus 1 over x minus 1 squared. Now this is a rational equation, and I can get rid of the x minus 1s by just multiplying by x minus 1 squared. That would cancel out both x minus 1s. And so that would leave me with x times x minus 1, or x squared minus x. And on this side, it would leave me with x plus 1. And let's get this equal to 0. So x squared is going to be minus 2x minus 1 equals 0. Oh, and this one's kind of crazy because we're getting quadratic formula. And now I'm wondering if I change this to a minus on yours so that this wouldn't happen. But whatever. 2 plus or minus square root of 4 minus 4 times 1 times negative 1 all over 2. This is radical 8, which is 2 radical 2. So 2, 2, and 2 can all be divided by 1. So 1 plus or minus radical 2 is my first answer. Now, what about that? So remember, radical 2 is bigger than 1. So when you do 1 minus radical 2, that's not going to work because that's going to create a negative value in here. So it's actually only 1 plus radical 2. So I hope I didn't change it on yours because I really like that. I'm going to keep this as it is and then update my answer key. All right, what about number 33? For number 33, these are different bases. We cannot get base 6 and base 3 to match. So on this one, you can either log or natural log both sides. Either way, you're not going to cancel out the bases. And it's pretty tricky to try to log base 6 or log base 1 both sides and get the x to be able to isolate the x. So that's why I don't do it that way. Use your expanding log property to move the exponents down in front with multiplication and parentheses. This is the only time we distribute natural logs. I realized there was some confusion with people, like they wanted on 32, they wanted to distribute this to make it like ln x minus ln 1. ln x plus ln 1. You can't distribute that because this is inside of the logarithm. This is the natural log of 6, which is just a number, and you're allowed to distribute a number through parentheses. You're not allowed to distribute an operation through something. So this is 3x ln 6 minus 4 ln 6 equals 4x ln 3 plus ln 3. The next step for this type of problem is to always get the x's on the same side. So I'm moving them to the left. Subtract 4x ln 3. And then keep the non-x's on the right side. So there's already a natural log 3. We're going to add 4 ln 6. You get the x's on the same side so you can factor an x out. Nothing's happening on the right side. And the benefit of factoring the x out is that now you can divide by the parentheses, divide them over to the other side. So natural log 3 plus 4 natural log 6 all over 3 natural log 6 minus 4 natural log 3. If you moved your x's to the right side of the equation rather than the left like me, then you should just have the exact opposite sign in front of every term. So you should have negative ln 3 minus 4 ln 6 minus 3 ln 6 plus 4 ln 3. All right, number 34 and 35. These are both factoring problems. You can see they're trinomials. They're set equal to 0, so they're ready to factor. Split up 2e to the 2x into 2e to the x and e to the x, just like you would split up like a 2x squared. What are the factors of 10 that are going to give me 9? So it can't be like plus 10 and minus 1 for two reasons. You're trying to multiply to positive 10. Also, there's a 2 here. So whatever you put right here gets multiplied by 2. So then the other factors of 10 are 5 and 2. So if I put the 2 here and the 5 here, I get 4e to the x and 5e to the x, and that's going to give me the 9 that I need. So if those are the two factors, then e to the x could equal, oh, now why is it negative? Does yours say positive or negative? I wonder if yours says negative. I just went through this with another student. Let me see. Where did this go? Oh, here we go. Yeah, this one says minus. Let me go back up here then. No, this one was plus. Oh, but this was plus. Oh, man. Okay, sorry, guys. Let me talk through 32 because this is a little bit different than what I have on my printed out version. I don't know why they're different. Anyway, you are able to reduce number 32. X plus 1 over x plus 1 squared is 1 over x plus 1. And then when you multiply by x plus 1 here, you just get x equals 1. Okay, and then on 34, yeah, I don't know. Interesting. I don't know why that's changed. So these both need to be minus signs. So this would be e to the x equals 5 over 2 and e to the x equals 2. And both of those we can solve because they're positives. So we would natural log both sides. Natural log of 5 over 2 and x equals natural log of 2. I must have an old version of the worksheet that I copied to make this key. Okay. This is factoring just like number 34 was. I know sometimes when the base number is not e, that throws you guys off, which is understandable. It looks weird. But we're not factoring a 3 out of anything. We're just splitting 3 to the 2x into 3 to the x and 3 to the x. And then it's the factors of 15 that are going to give us negative 2, not 6 or anything like that. So that's got to be 5 and 3 minus 5 plus 3 to get negative 2 in the middle. You can't factor a 3 out or anything. There's not a GCF when you have a base number to an exponent. So this just means 3 to the x could equal 5, or 3 to the x could equal negative 3. So negative 3, negative anything is out. No solution from that. This one, I would log base 3 both sides so that you cancel out your base 3 here. So log base 3 of 5 is the only solution. You can also use natural logs. If you have an answer of natural log of 5 divided by natural log of 3, that's perfectly fine too. All right, I'm going to stop this video, and then there will be one more video for the calculator section after this.